Hi everyone, welcome back to our challenges related to Java. We're continuing with Leetcode.com because it's got quite a lot of stuff. So let's continue. These are locked. If you want to get this exact list, I've sorted them by acceptance descending. So the easiest, well, supposedly the easiest ones are up front. There we go. That's not locked. A valid parentheses string. Okay, the whole brief is kind of overwhelming. Valid string is either empty or one of these. And then A and B are valid. So is that like recursion going on? So that is valid. Essentially, empty string is valid. A single pair is valid. And then these are valid because of that. Because if you replace this thing into A, then this becomes valid, and then this is obviously valid. And this is valid because we have that on top of it. And then we can recurse our way out of it. Okay. So return S after removing the outermost parentheses of every primitive string. If input is S, then we get rid of these ones. Oh no, it's these ones. And then we remove these ones. So the only thing we can have is one of these. It's related to count, I guess. We need to it's like almost like a stack counting, because we're opening a parenthesis and then we're closing it. Yeah, something along those lines. Let's just call it stack for now. So we definitely need to go through all of them and then return a result, right? How about that? So if the character that we're looking at is an opening parenthesis, then we count up, giving us something that is not 0. If this thing is 0, then we've found the closing counterpart, right? We can just do an else here because we know exactly the constraints. It's either the opening one or the closing one. And now that we've removed the outer shell, we need to keep the stuff in between in the results somewhere. So we don't include the first one. So if stack is 1, then we've just increased from 0. So we don't include that bit. We only include the things that are inside. So how about we keep track of that as well? Is including false. That becomes true. So if we are including the thing, then the result needs to be populated with this. Once we have reached the end and we know that this thing is 0, this including needs to be false. And is that it? Well, we need to return the result. This will fail for one edge case. Well, not edge case, for normal case that I'm thinking. because we're also going to include that one. Is including false, and maybe just concatenate, just remove the last one, 0 result length -1. Is that going to do something? Wait, is that it? Okay, I'm happy with that, because I didn't really understand what the question was. I kind of went off on my intuition of getting rid of the matching parentheses that form the outer shell of whatever's inside. I was kind of concerned that I would have to go like deeper into the recursion, but apparently it's just the outer ones. I guess that's why it's marked as easy. The question itself was quite difficult to get, but what's done is done. Let's go next. Minimum time visiting all points. What's that about? This time, let's just read the example first and then read the description. So the example is point 1, 1. So it's going real maths rather than games maths, because I'm used to thinking positive y goes down, because that's how it is for games, UI, and most of the stuff in 2D that we do. But this is real math, so it's 1, 1, 3, 4, which is that one, -1, 0, which is that one. And what we need to get is the optimal path through these points. Is that right? 1, 1, 2, 2. So these are integers, right? Okay. 3, 3. Then here, and then all the way down. Yes, okay. That would make sense. Output is 7, and I assume it's the number of moves that we have to make. 1, 2, 3, 4, 5, 6, 7. Well, not counting the first one, because we're starting from there. Three, 2 output is 5, because so it's 3, 2, and -2, 2. So it's 1, 2, 3, 4, 5. Yep, that makes sense. Do we have to go in sequence, in the order given by points? Wait, we can move diagonally. Oh, yeah, okay. Yeah. And it still counts as one move in the same order. I like that one, the same order, because otherwise it would be complicated, possibly. I don't know. Whenever it's in order, it's easier because you're iterating, well, in order. So you know that the next thing you have to do is going to be the next element in the array. I also like that one. That simplifies it, because we don't need to remember the points that we visit. Okay, so these are the points. How are these given? X and then Y. There are n points with integer coordinates. So it's X and then Y. So is it Y? I'm trying to iterate through it over this two-dimensional array. I always forget how the arrays are written. So that will iterate through one dimension, and then we need the second dimension, which is that one. Okay, I'm starting to remember now. 0.0. But it needs to be the same, right? There are n points, so it's exactly the same value, I would assume. And then the actual, wait, what's happening? Then the actual point, I should have used different things. So let's go with J on this one, and then I. So I can actually use X. Points. Wait, what? (2D) plane. There are n points with integer coordinates. An element of this is but that's a two-dimensional array, so you access it by two indices, which gives you a single value. Oh, okay. So you get an array from, so that is a point, and then that's how you access. Okay, I'm starting to get what they want from me in terms of syntax. And then that's an I, and then and then this thing is that. So we iterate once. We don't go loop inside the loop. What's happening with formatting? Okay, and then we have 0 and then 1. So this is X, which is that. That's one of the reasons why I try to avoid using any kind of constructs using primitives, because it's hard to read. If this was something like that, That would be much easier to read. But anyway, we're not talking about API, talking about algorithms. And in some algorithms, you do need certain constructs. So we've got our point. That is the one that we're currently at. And then we need to go to this next one and calculate how many moves we're making. They're calling it time, but I'm going to call it number of moves. So all we need to do now is figure out the distance between 2 points, including the diagonal movement. So between 1 and 1 and 3 and 4, we have 2 and 3. The vector is 2 and 3. 2 and 3, you can move 1, 1 to 2, and then you need 1 more. So it gives you 3. So you reduce, you pick the closest one, and then you reduce that to 0, as in 2 and 3. 2 is the smallest one, so 2 goes down to 0, giving us 2 moves. And then we have the remaining 1 over there. Is that the easiest way to think about that? Which gives us 3. I mean, this works in this scenario. What about the next one? Minus 1, 0, and then we subtract 3 and 4. That gives us minus 4 and minus 4. There is no, well, the closest one is, if you take the absolute value, it's 4. So that gives us 4 movements. And the remainder of the largest one is 0 because they're identical. So it's 1, 2, 3, 4. 3 plus 4 is 7. So I think it works. We need to remember something. So we need old x and old y. And then we can even cheat. We can start at 1. We can just initialize this to that, and then 0, 1. No, this one is 0 and this one is 1. Yeah. So we get the vector Vx is x minus old x, and Vy is y minus old y. And then we obtain the absolute value. I'm going to use maths. I need to import that. Isn't it just available because it's system import? So math apps of this and an absolute value of this, because I don't care particularly about the sign. All I need is the absolute value, and then the smallest one of the two gives us the number of diagonal movements that we can make. The remainder is just what we add on top of it to get the number of moves for that single move between this point and that point. So we need to figure out what the smallest one is. Math, minimum of that and that. And then we need to increase by smallest, and we also need to add that remainder, which is Vx minus smallest plus Vy minus smallest. Now we don't know which one is the smallest value, but because it's guaranteed to be one of them, that one, suppose it's Vx, in which case Vx minus smallest is going to be 0, not going to add anything. And then Vy minus smallest is going to add whatever the actual number is. Is that it? Output is 5, so that's what we produced. Expected 7 for that one. Okay. This is the point x, y, x minus old. Oh, we need to reset old x to x, old y to y. Okay, let's try that for real. Zero milliseconds. That's impressive. It's probably not 0. It's probably like something like 0 point something, and it was just rounded up to. Anyway, it passed. I'm happy with that. The diagonal ones are not normally considered, or at least I don't normally consider them in games, because I prefer just the horizontal and vertical movements. But it was a nice thing to consider. So in the future, I might actually use something like that in a game or two. Anyway, thanks for watching, and I'll see you guys in the next episode, as it were.